Start recording. We're going to be looking at solving quadratics by square roots. Let me make sure I got my key here, so make sure I mention everything I wanted to. All right, so usually this method you want to use if you have the form. Let's see if I can write, not like a child. If you have ax squared plus a constant equal to 0. If you have something in this form, this is the method you're going to want to use. If you have like an x squared and a constant, like no middle x term, this is a good method. You could also use this method to solve problems like if it's a difference of squares. So if you ever don't recognize it's a difference of squares, or if you've been struggling with the difference of squares, this method will kind of let you solve those problems as well. But basically, to remember to solve, like if you're trying to solve for, like if you have x squared equals a number, to solve that, you take the square root of both sides. And the only thing you got to be careful when you're solving an equation, you got to put a plus or minus the square root of n. Because the idea is if you're like solving x squared, let's say x squared equals 9, well, there's really two answers that make that true. 3 squared is 9 and -3 squared is 9. So like a lot of times when you there's more than one answer for questions like these. But we'll see like that when we get into problems. So our steps, basically, you want to get the x squared by itself. Then you're going to take the square root of both sides, and then we're going to simplify the radical. I don't know if I'm going to have you do that today or not. That's like what we were talking about, like in those two questions that I had like hand drawn below. Why is my iPad not responding? Okay, now it is. Okay, so let's look at some problems. So number one, like I said, the first step is you always want to get the x squared by itself. So we would add the 64 to the other side. So once you have your answer in this form, like x squared equals a number, then you're going to square root both sides. So some of these will be perfect squares. Some of these will be decimals today. So just make sure when you write your answer, it should always be plus or minus. And then the square root of 64 is 8. So plus or minus 8 would work. And what this means, that means x equals 8, x equals -8. So if you'd rather write it like that, you can, or if you just want to use that, that's what that plus or minus symbol is if you've never seen it. Basically, it means both the positive and the negative of that answer. But I'm going to erase this for space. But if you want to write them separately, you're more than welcome to. Keep in mind, I know we haven't been like graphing these, but if you did graph this equation, it would look something maybe like this, but you would see it crosses at 8 and it crosses at -8. When we're solving these equations, remember, you're really finding the x-intercepts of it graphically. Let's look at one more. Or maybe we'll do the first 3. So you would subtract the 8, divide by 7. So we have x squared equals a number. Now we're ready to square root both sides, because the opposite of a square in a number is the square root. It like cancels it out. So we would have x equals plus or minus 1. Let's look at another one. So we have 81x squared equals 16. Divided by 81. One tip, especially if you notice your fraction, like if you recognize those are perfect squares, sometimes, I mean, you can divide those and get a decimal, but sometimes it's nicer to keep, like if this is a kind of a special case, but if it's perfect squares, basically when you square root a fraction, you just take the square root of the top over the square root of the bottom. So this would be the square root of 16 is 4, the square root of 81 is 9, and don't forget the plus or minus. A lot of so far, most of these problems, I mean, this one obviously didn't, we got a fraction, but most of the time when you're actually solving equations with this square root method, you're not going to get whole numbers unless they're kind of made to work out to be perfect squares. Let's just do one more so you can see that. But so this would be 8x squared equals 16. divide by 8. We'll get x squared, sorry, is 2. Square root both sides. It's up to you. Well, this one you really can't simplify. Some people would just maybe keep that as the square root of 2, but especially when we're getting into more like when we're graphing or stuff, it's nice to have a number on it, like a decimal. So if you have a calculator, just do the square root of 2. And it's up to you if you want to put, I usually at least 2 decimal places, but if you want to put more, it's your life. But oops, let's not forget the plus or minus. But so I'm going to split these up. I mean, I know there's only 5 left on this side, but here, maybe I'll just kind of do it alphabetically. So how about Labria, Trayvon, Brittany? How about you guys try number 5? DeJounte, Aaliyah, and Ariane. I hope I'm saying, like, I feel like I don't even know how to say some names still because I never really like talked in class. So if I'm butchering a name, please yell at me because I know I don't know how to say some names still, which is embarrassing. You could try number 6. Layla, Kamira, Caleb, you could try number 7. Jayana, Felix, and Brooklyn, you can try number 8. Oops, and I did not do a good job. Michelina, Aslan, Michaela, Ariana, Brianna, Kayla, you could do number 9, I guess. But if you want to just split it up, I mean, you could try them all, but if you could try the one I assigned, and then maybe I'll have you guys see if we can walk me through these. And if you missed it, you can let me know in the chat. I'll tell you what problem I wanted you to do, but let me see. Let's see, you would have been number 7, I think. Just do 7. Oh, let me pause the recording. Let's get moving. So we would add our 9 for this one. So you'd have 2x squared equals 64. Divide by 2. You'd get x squared is 32. If you square root both sides, it would be plus or minus approximately 5.65. And I worked these out a while ago, so if it's possible, maybe if I didn't round to the right hundreds, just let me know. But if you got something close to this, you're probably right. So people that try that one, let me know. Let me know too if you're like, hey, I didn't get that. Or 6, you subtract the 3, you get 9x squared equals 108. Divide by 9, you'll get x squared is 12. So if you square root both sides, the square root of 12 is approximately 3.46. And like you can kind of gauge if your answers are right if you know your perfect squares. Like for example, the square root of 16 is 4. The square root of 9 is 3. So I know my answer is going to be between 3 and 4. Like same idea with the like number 5. The square root of 36 is 6. The square root of 25 is 5. So I know my answer is going to be between 5 and 6. So like you can kind of use that to kind of gauge if your answers are at least in the right ballpark. This one we would subtract 4. Then divide by -3. So you would get approximately 5.2. I just put 1 decimal place for that one for my key. I don't know, maybe, yeah, that's what I already said as well. All right, this one you would subtract 10. Divide by 5. That would be 60. The square root of 60 is approximately 7.75. On this one, you would subtract 1. Divide by -1/2, that would be positive 80. If you square root, you would get approximately 8.94. And I was a bad teacher. I forgot my plus or minus on these two. Okay, so far all these questions have worked, but there's definitely some problems you won't be able to solve. Like say, for example, you had x squared plus 1 equal to 0. And sorry, I know this is kind of on the side. Like if you solve this, you're going to get x squared equals -1. If you have a calculator handy, like if you put in the square root of -1, you're going to get an error. It's going to tell you like undefined. It might say domain error, but your calculator is not going to give you an answer, at least unless you have like a super sophisticated calculator. I don't know, like maybe some calculators would actually give you the answer if it has it built in, but I've never seen a calculator that does that. But one thing they realize is that not every quadratic is always going to be solvable using the numbers we know. So let's kind of talk, we're going to kind of build on our number system. Basically, we're going to have to add new numbers to our number system. It's kind of like back in like centuries ago, like in other civilizations, like negative numbers seemed very strange at first. Like if you look like at a lot of ancient civilizations, like they had no concept of negative numbers, because how can you have a negative number of things? Like you can't have -3 rocks. Like you can't have negative. So, and I'm not like trying to like trivialize, but like I know we take negative numbers kind of for granted today because they just seem kind of normal because you've been working with them for a while. But it's no different really with these imaginary numbers we're going to talk about. I mean, is that they were first kind of created when people were trying to solve cubic equations. Most people would just stop and say, oh, you can't solve it because it doesn't work. Like you can't solve this quadratic. But eventually people just said, well, screw it, I'm just going to keep going. And eventually, if you kind of use these imaginary numbers, a lot of times you can get real world kind of solutions. Like you just kind of need to use them kind of as a stepping stone. They're actually really important, and they like if you like ever like an engineer or something, like imaginary numbers do come up when you're like creating things. But so we just kind of talked about this equation. Like if you tried to solve this, you would get x squared equals -1. But you can't, we've just said you can't square root a negative number. Like you would just say there's no solutions before. That's like what we would usually say. But we're going to create or we're going to add basically to our number systems. So we can solve things like these. So the imaginary unit is basically, it's a lowercase I with like a little tail on it. I don't know if you've ever seen it on a calculator or like in a math textbook, if you ever, but it kind of looks like that. You can kind of see it here if you look below, but it's kind of like lowercase I with a little tail on it. But we're going to define I as being the square root of -1. This is going to let us basically, anytime we get a negative square root, it's going to let us get an answer in using these imaginary numbers. A pure imaginary number is written in the form, like you can have a coefficient, like a constant. So you could have like, that's AI. Sorry, my handwriting is so bad. But a lowercase a, and then the imaginary I, where a is a real number and I is the imaginary part. So let's just look at some examples how we can use this. Why is it not erasing? Okay. We're going to see how we can kind of simplify some negative square roots. So we use this imaginary I basically anytime you have a negative square root. Like, so for example, if you had the square root of -a, you could rewrite that as the square root of -1 times a. We're basically just going to take the square root of the normal number and then just put an I after it. So basically the idea, like in this problem 1, this is really the square root of negative 1 times 9. I wish I could write not like a child. But square root of negative 1 times 9. So you can break up radicals. This is really the square root of negative 1 times the square root of 9. So usually you do the number part first. So like the square root of 9 is 3. And then the square root of negative 1 we defined as being I. Like that is I. I is the square root of negative 1. So this would really be 3I. Or basically, you just take the square root of the normal number. So like just ignore the negative, put the square root of 9 in your calculator, and then just put an I at the end of your answer. Square root of 196, negative 196. Well, we're going to have an I, but in your calculator, what's the square root of 196? That's a perfect square. I don't know if you recognize it or just put it in your calculator, but the square root of 196 would be 14. And for some of these, you'll get a decimal. So like the square root of negative 5, well, it's going to have an I. You're just going to put the square root of 5 in your calculator, which is roughly 2.24. Like for you just round it to a couple places. So let's see if we're getting this. How about you guys give number 4 a try, give number 5 a try, give number 6 a try. You're going to get decimals for those. I mean, you could simplify it into radical form if you want, but like I said, for the purpose of this class, it's not a big deal to me. I honestly, usually for what we're doing, it's nicer to just get a decimal, but you might be in a future class where they have you like do like your factor tree and like keep it in that radical form, because sometimes you don't want to round or approximate your answers. But try 4, 5, and 6. See if you can do. But for number 4, you like if you put the square root of 80 in your calculator, like don't put the negative, because you'll get an error. But you would get 8.94 I. Number 5, I see in the chat, someone the square root of 32 would be approximately 5.65. And then since it's negative, you always have an I. So if you ever have a square root of a negative number, you're going to have an imaginary solution. The square root of negative 192 would be approximately 13.85 or I. Or I put 86. I don't know if it rounds up or not. It's not that big of a deal. Oops. So that's, oops. Let's erase that. Okay. So like I said, sometimes when you're solving like equations like we did on the front page, like if you ever get a negative number on the right side, like I have x, like for number 7, I would have x squared equals x squared equals negative 81. So when you square root that, like I know right away if I have a negative number, I'm going to have an I. So I would have x equals plus or minus 9I for this one. And you might be wondering, like, Mr. Swope, why didn't you put plus or minus for these answers here? It's kind of like a weird thing. But usually when you're simplifying like a square root, like just simplifying it, you don't put a plus or minus, you just keep the sign it is. So since these were positives, we're really just going to just put the positive answer. But when you're solving an equation, like when there's an equal sign in your square root on both sides, that's where you got to put the plus or minus, because you can't assume the sign. So if it's simplifying, you usually don't put the plus or minus. If you're solving, that's where you put the plus or minus, if that makes any sense. So same idea here, like these subtract and solve. Notice I have it equal a negative 4. So I mean, I know when I square root this, I'm going to get an I in my answer. So this would be plus or minus 2I. One thing, and we'll talk about this more, but you would see if you graph these equations in Desmos, like if you graphed y equals x squared plus 81, for example, you're going to see it doesn't have any x-intercepts. I don't know if you remember when we graphed some quadratics before, some of them wouldn't have x-intercepts. Every quadratic has 2 solutions, but sometimes they're imaginary. Like, so Brooklyn, you're asking about number 7. Like, why wouldn't it be 9 or -9? Because it's maybe it got kind of missed by my sloppiness, but this is -81. So anytime you have a negative number, you're gonna get an imaginary. Because if you put the square root of -81 in your calculator, you're gonna get an error. But you want to really break this apart as being the square root of +81 times the square root of -1. So that's where the I comes from, if that makes sense. But let me know if I didn't understand your question. I'm gonna, but like what I was saying though is like every quadratic has 2 solutions, but sometimes they're not going to show up on your graph because they might be imaginary. So like a lot of those quadratics we've been graphing before, if you didn't see x-intercepts, that was probably because you had some imaginary solutions in them. But we'll kind of talk more about that. But every quadratic really does have 2 solutions. They're just not necessarily all real numbers. So Aslan asked, like, why doesn't number 4 have a plus or minus? Because you're just simplifying. It's kind of like a weird thing, and let me know if it doesn't make sense. But since you're just simplifying this square root, you're kind of assuming like that this is just positive square root of -80. So usually when you're simplifying, you just put the answer like for example, if they really wanted, if it was a negative, why does it keep not letting me write? Okay, let's try it again. But usually, like if they want the negative answer, they put a negative in front, like already. So usually it's only when you're solving like when you're solving and you're square rooting both sides of an equation, you got to put that plus or minus. I'm going to skip number 9 and 10. I'll put these, like I'll put up a key to these notes, like those will be worked out. But I mean, it's really no different. I'm also going to skip 11 and 12, but I'll work those out and put those online. But there's really no, like, I mean, it's not really any different than what we saw before. I wanted to talk about some powers, and we'll see if we can squeeze this in, or I might need to talk about this a little bit more tomorrow at the beginning of class. But powers of I. Obviously, I to the first power is really the square root of -1, and that is just obviously equal to I. I squared is kind of strange. We kind of just define it. Let me see if I can make sense of this. Because I know if you try and break it down and you work it out, you'd be like, well, wouldn't that just be the square root of 1? There's really kind of 2 kind of definitions. The square root of -1 is I, and then I squared is -1. Like you just kind of, like those are the 2 things you just kind of have to agree with. Like that's just by definition. Because if you try to break it down, because I'll see if I can come up with a better explanation. But because if you really think about it, well, since I is the square root of -1, why wouldn't the square root of -1 times the square root of -1 just be +1? But it's just define this by definition, because this makes it work with other things. I'll see. I know that's not a great explanation, but you're going to see basically though that powers of I kind of follow a cyclical nature. I to the first power is I squared would be -1. I to the third power, if you think about it, is really I squared times I. And since I squared is -1, that would just be -I. And I to the fourth power would really be I squared times I squared, and that would just be -1 times -1. So that would be +1. And then you're going to see it follows that pattern. So this would be I to the fourth times I. That would be just 1 times I. It would be I. This would be I to the fourth times I squared, which would be -1 if you look at these other definitions. I to the seventh would be I to the fourth times I to the third, which would just be -I. Because I to the fourth is just 1. So you can almost just kind of notice this would just be I to the fourth times I to the fourth, which would just equal 1. But if you notice, like these powers are like the same. Like I to the first is the same as I to the fifth. I to the second is the same as I to the sixth. I to the third is the I to the seventh. I to the fourth is the same as I to the eighth. Basically, every four numbers it repeats. It's like it kind of follows like seasons. Like the first season is the same as the fifth season, the ninth season. The second season would be the same as the sixth season, so on and so on. So like for example, I to the 15th, you want to like talk about multiples of four. So like 4, 8, 12, that would be here. And then 13 would be here. 14 would be here. 15 would be here. This would be negative I. I don't know if that makes sense. I might need to, I'm definitely going to talk more about this tomorrow, but I to the 62, if you think about multiples of 4, 4, 8, 12, 16, 20, and then we could kind of go from there 20, 40, 60. That would be a multiple of 4. So 61 would be here, 62 would be here. So this would be negative 1. Yeah, the powers is a little bit rough, but um here, I'm gonna cut it off here. Because we're out of time anyways.